So if you remember at the beginning, we have seen how to implement a sparse set. So what I propose now is that we turn this sparse set to implement a set into a reversible sparse set that is able to restore its state on backtrack, and it will be called a state sparse set. Okay, like this. And so the state sparse set will have this behavior. You can save the state again by using the trail. You can the state manager. You can save the state. When you remove a value, it's exactly like a regular sparse set. Okay, so if you remove the value 4, you will swap it with the last one, like this, and then you decrease the size. If you remove 6, you do the same, like this. Then you assign it to 3, you've got this. And when you will restore the state, you need to recover everything up to the size it used to have before, exactly as expected. And this is the way the domains are reversible objects, and on backtrack during the depth first search, they restore the value they had before. This is exactly by using this mechanism. And the only thing that we need to change inside the implementation of the sparse set to have this behavior is that this object, size object, this size object will need to be a reversible. This will be a state integer. Okay. If you say that this is a state integer, then the magic will happen. Okay, it will be able to restore its state on backtrack, because the state manager will be in charge of restoring the value of the state integer. If you remember, we also need to restore all the constraints that were added during the search. Okay, and so we need to maintain a stack of constraints, and we need to restore and remove the constraint on backtrack. And so what we will do is implement a state stack that is also able to restore itself on backtrack. How is it implemented? Using internally an array list. So we've got an array list, and again we've got a state integer. And so if you push an element on this stack, you put it at the end, and you increment the size, and the size is a state integer. And if you ask the size, I simply return the size, which is a state integer, and the get, you get this one. Okay, and so if you want to iterate over all the elements up to the size, all the one that used to be before will be replaced. Okay, because if you push an element, you push it at the current size. Okay, you push it at the current size, and you say set the element at the current size. Okay, and so if you backtrack and you continue to add, you will erase the previous elements. So this is the way the state stack is working, and this is why the constraints that you will add will be also reversible. Okay, so if you remember the implementation of the variables, we've got 3 state stacks, which are reversible stacks. Okay, so when you post a constraint, you add it to the stack. Okay, and when you will restore, it will be removed from the stack implicitly.